Okay, so today we are looking at special angles in trigonometry. In this particular topic, trigonometry, we'll be working with the 45 degree, 30 degree, and 60 degrees angles. However, there are some important concepts that you need to know prior to the knowledge of special angles. As you may be aware, trigonometry deals with the two types of triangles, that is to say, right angle triangles as well as non-right angle triangles. So today we're going to concentrate on one of these two types of triangles. If you recall, in grade 8, somewhere there we did learn about the Pythagoras theorem. This is a theorem which is applicable in right angled triangles. Okay, this is what we did look at. For example, we did look at the types of the sides in this particular right angled triangles. If I may ask you, what do you call this longest side? What is it called, if you remember? Speak.
Hypotenuse.
Okay, so the longest side, this is what we call the hypotenuse. Hypotenuse. Okay, side. This is the longest side. In other words, this is the side opposite to the 90-degree angle. Okay, the rest of the two sides, their names are dependent upon the location of the acute angle under review. What am I talking about? Well, this angle here is 90 degrees. The rest of the two angles are called the acute angles. Why are they called the acute angles? Well, by definition, an acute angle is an angle below 90 degrees. If it's 90 degrees, it's not an acute angle, it's a right angle. Are we getting that? Okay, so what you're saying is the rest of these two sides here, their names are dependent upon the acute angle under review. That's why these two angles, sides, are referred to as the adjacent side. This is the adjacent side. The same is true of this one. This one is also the adjacent side. Okay, this is how we get about it. So for example, if the acute angle we are reviewing is actually this one, take note. Okay, so in other words, the adjacent sides, their names, they are not static. They change based on where the acute angle we are reviewing at that particular point in time is. So for example, if the acute angle we are reviewing is this one, this side here opposite to this angle, okay, it has a special name. This side will be called the opposite side of this angle. And this side here will be called the adjacent. By the way the adjacent simply means the next to. So we are saying this side here is next to this angle. That's why this side is called the adjacent side or the next side to this particular angle. That's basically the proper definition. But this side automatically will see that indeed is the opposite side of which angle? This angle here. Are we there? Are we getting that? The same is true if you are considering this particular angle on top here. We see that this side here, it won't be the adjacent. This side will be called the opposite, and this one will be called the adjacent side of which angle? Of this one. So in other words, these angles here are called the reference angle. Okay, if the angle we are reviewing is this one, this side will be called the opposite angle, and this one, the opposite angle of this angle here. And this side here will be called the adjacent side of this angle here. The same is true if you are reviewing this angle here, we are finding this angle here. Okay, this side will be called the opposite side of this angle, and this one will be called the adjacent or the next side of this particular angle. That's basically the idea. Okay, so we're dealing with the adjacent side, opposite side, as well as the hypotenuse side. However, for the hypotenuse side, it's always obvious, the longest side. Or in other words, the side in a right angle triangle, opposite to the right angle. That is it. It's always obvious, actually. Yeah, these are the ones that shift based on the location of the angle under review or asked. Yeah, that's the point. All right, so that's what we're going to look at briefly, and I appreciate the fact that you guys still remember, Pythagoras theorem, which we learned as way back as in grade 8. If you remember again, for example, if you have, say, we have this particular right angle triangle, okay? These are important basics which you need to know, okay? So, for example, if this is A, this is B, and this is C. Now you're asked to find side B, C, okay? Using Pythagoras theorem, we're going to touch side BC, or the square of BC. We're saying BC squared will equal to the. Do you remember Pythagoras theorem? Come on. It will be? It will be
AC squared.
Okay, AC squared
Plus AB squared.
plus AB squared. Excellent. Don't forget this rule, please. Don't forget. Very important action. Okay, so the longest side, the square of the longest side is equivalent to the sum of the squares of the two adjacent sides. Take note of that one. That's a proper definition actually. That's what we have there. Then you are maneuvering there based on what they're asking you. They want AB there, you make AB the subject, Do not forgetting the square, of course, by square rooting where necessary. Yeah, such kind of stuff. Basically, this is the knowledge that you did look at. Okay, now why is this important? Well, this is important because we are now going to consider, special angles. All right. Now let's look at this one. Under this special angle, maybe prior to the special angles, I want you also to teach something here. Okay, I want to teach you something here. We also did look at what we call the SOHCAHTOA. You may not have already looked at trig in those details, okay? So under trig, you are also going to look at what we call SOHCAHTOA, or the trigonometric ratios. So we're going to concentrate on the three, take note, the three trigonometric metric ratios. What are they? These are beautiful ratios. We have got what we call the sine ratio. We have got what we call the cosine ratios. And finally, we have what we call the tangent ratio. Very important ratio. These are three trig ratios. Very, very important. Now take note. These trig ratios are mostly applicable in right-angled triangles. In other words, they work hand in hand with the Pythagoras theorem, with the theorem of the Pythagoras. They work hand in hand. So for you to better understand special angles, it's imperative that you actually still remember, you regurgitate your thoughts, your memories on what you actually learned as way back as in grade 8. You did look at Pythagoras theorem, so you shouldn't, forget, you should remember. Remember those concepts that you did look at in grade 8. So when you incorporate those concepts with what you're going to have in the three trigonometric ratios, then special angles will be actually easy for you to actually understand. Okay, now how do you go about these three trigonometric ratios? Well, like I mentioned, these three trig ratios are applicable only in right-angled triangles. Like I mentioned, trigonometry as a topic, it deals with either a right-angled triangle or a non-right-angled triangle. That's it. That's why I did mention these three, guys. Okay, let's look at this one here. We just reviewed a little bit on this one so that you have a glimpse of what we're actually, are yet to consider. All right, so here is a right-angled triangle on the board. Okay, so for example, if you have an angle, this angle I'll abbreviate it using this symbol here. This is a theta. Okay. Theta is basically the symbol, a Greek symbol that we use to denote angles, okay, to denote angles, okay, or to symbolize angles. So this is the angle, and these are sides here, like I mentioned. All right. Now suppose the side that you want to find, say maybe this side here is given as maybe 6 centimeters, and this side here maybe is given as This side here is given as what? Maybe 4 centimeters. Okay, something like this here. Then you're asked to say, can you find the angle theta? What are you supposed to do? Okay, so there's something that you need to do here. So let us first define the 3 trig ratios. So first of all, define sine. Take note. These are trig ratios. These are ratios that if they are mentioned, there must be an angle right after they are mentioned. For example, it will be sine theta, cosine theta, tangent theta. However, we have got the abbreviations. Instead of writing all these words sine, we abbreviate it as sin, but read as or pronounced as sine. Same is true of cosine. We don't have that much time to be writing INE. So we remove the INE and abbreviate it as cos. But of course it's pronounced as cosine. The same is true of tangent ratio. Instead of writing tangent, we remove the G. In other words, we remove the gent. So we have the tan. Are you there? Abbreviated as tan, of course, but pronounced as tangent. You get. So there are some of the abbreviations for the 3 trig ratios there. Now, we want to try to define what they are individually. So let's concentrate on the sine. So the sine, abbreviated as sin, but pronounced as sine. This will be sine, angle, theta. Take note. Okay, this one is equal to what? Okay, so we need to define what this actually is. That's why I did mention something like SOHCAHTOA. That's what you call a mnemonic. A mnemonic is basically the abbreviation that will help you remember. You remember it? Okay, so that's what you call SOHCAHTOA. So from the SOHCAHTOA, we have all the 3 trig ratios. I've got the sine, the cosine, and the tangent. They're well defined. So for example, look at the board. We're going to have SOHCAHTOA. Why is this very important? This is very important because it actually defines what these 3 trig ratios actually are. I will explain. This S stands for sine, this O stands for the opposite side, and this H stands for the hypotenuse side. This C stands for the cosine. This A stands for the adjacent side of that particular rectangle triangle under review. The H is for the hypotenuse, and the T is for the tangent. The O is the opposite, and A is the adjacent. Very important. So for example, sine theta will equal to, using the SOHCAHTOA concept, okay, the way they are, the manner in which they're written is the manner in which they need to be written here in the formula. So sine theta is equal to, the O represents the opposite side. Take note, I'll just abbreviate opposite side, over the H, that is the hypotenuse side, which is always the side opposite to the right angle D, to the 90-degree angle here. And of course, this will be the hypotenuse side here. Right, we go to the cos, which is CA under SOHCAHTOA. So say that will be cos, abbreviated as cos. The cosine is abbreviated as cos. Cos what? There must be an angle once they are mentioned. So cos theta is equal to adjacent side, we just abbreviate it, adjacent side divided by the hypotenuse side. Okay, then there we go. We look at the last one. We have got the tangent, of course. The tangent ratio, take note, is tan theta. This will equal to the opposite side, okay, divided by the adjacent side of that particular rectangle triangle review. Very, very important, as you actually can appreciate. So it's all about knowing the mnemonic. This mnemonic SOHCAHTOA. If you know this one very well, it will be very easy for you to table out their formulas or their definitions. Very, very important please. The moment you just mentioned either of these trig ratios, you should actually also mention the angle under consideration. Alright. So what now? So here we go. Let's just pick up this one here. So for example, if you're finding this particular angle theta, you want to figure out what it is. You say, okay, angle theta, okay, let's concentrate on each side. So this side here, which is given, what is it called? according to where this theta is. What is this side, please? What is it called?
Opposite.
Excellent. This will be the opposite side of this angle here, which is very true. Take note. The hypotenuse is static. It does not change. Okay? It doesn't change. The one that change are these two sides here. They change based on the location or the angle under review. In this case, we are reviewing this particular angle here. So meaning this side here is actually the opposite angle of this one. What of this side here? Excellent. This side, no doubt, will be the adjacent side of this angle here. Excellent. Beautiful. So what? So we see here that for us to compute this angle here, we should have the opposite and the adjacent. So from the mnemonic, very important weapon here, where do you have OA? Check. Excellent. So which trig ratio, in other words, are we going to actually use? Is it the trig ratio? What is it? The trig ratio is what? Is the tangent ratio. You get it? So these are trig ratios: sine ratio, cosine ratio, and tangent ratio. So if I say which trig ratio are we going to use to compute the angle theta here based on this, we're going to use the tangent. That's the TOA, isn't it? TOA, which is of course the tangent, the tan. Okay, so we're going to use OA, and you see that OA is found only in tangent ratio. Tangent ratio is defined as the opposite side over adjacent side. Therefore, we pick the tangent ratio to actually be able to compute the angle theta there. So you pick, you say tan theta, you do not know. This will be opposite side. Now we know the opposite side here is, what do you have? What is it?
4.
That's a 4 there. Very good. Over the adjacent side there, please. That is a 6 here. You get. Then from here, remember, you need to do something here. Just like I'll take you back to the normal linear equations. For example, if you have something like 4x is equal to 8, there's something that you do for you to actually have your x there. You need to do what? What do you need to do here? You divide. Yeah, very true. Okay, divide. Okay, but are you really dividing here? You're actually finding the reciprocal of 4. Take note, the reciprocal and the inverse are one and the same thing. Reciprocal and inverse is one and the same thing. So what is the reciprocal of 4 here?
1.
Excellent. It is 1 over 4. 4, it's actually 4 over 1. Now the opposite of this one, it is 1 over 4. You remember? I told you such actually. Except you are glued to dividing over 4 over 4, but in a sense it's multiplying by its inverse or reciprocal. Now we also know from the laws of inverse, you see, mathematics is a pattern. So whatever you learn, we're simply just adding on to what you already know. Now look at it. This 1 over 4, 1 over 4. In index form, how else can 1 over 4 be written? How else can 1 over 4 be written according to what I taught you guys? Take note. 1 over
Negative 4.
Excellent. So it will be 4 to the power negative 1. Do you remember? I taught you this. 4 to the power negative 1. I said this negative will be 1 over. Then this is the base, and this one is in the power. Then this will be 1 over 4 to the power of 1 is simply 4. Therefore, 1 over 4, this fraction can also be written as 4 to the negative 1 power. And this is what you call the inverse or the reciprocal. The same is true of exactly what we're going to do with this guy. We don't want this. So we're going to reciprocate. We're going to divide, but we're not dividing in a sense. We're finding the inverse of this one here. You get it? So multiply to this side, also on the other side. Okay, if you multiply here, so the inverse of this tan is simply tan inverse. So tan inverse times this here, it will give us 1. 1 times theta, it will be theta. Then also multiply it on the other side. Here we're going to have tan, the inverse of, we put this stuff 4 over 6 inside the brackets there. Then of course you simplify this stuff here using your calculator. You get, okay, using your calculator. Okay, I'll show you how you get your calculator. Do you remember these? It's quite strange, right? So get your calculator. So what it is, for you to have this inverse here, your calculator has got everything that we need here. So what you do, you go to the shift key button, you press the shift key button, you press the shift key button, okay, you press it. The moment you press it, there will be the S. And okay, you're going to see the S, the letter S, just on top of the screen there. Okay, then you go to the trig rational review. That is the turn, as you can see here. Then from there, you can actually say, okay, let me use my brackets. There's no problem. We've got 4 divided by 6. You can say 4. You can use this one, no harm. You divide by 6, then you close. Then you go to your equal sign button. So that's your angle. So the angle will be 33 point what? 33 point. Can you see? Is it 33? Yeah, that's 33.7. Yeah, 33.69. That's actually the angle that you're going to have. Now we have got 30. We have got 30. We have got 33.69. Since it's an angle, we give it to 1 decimal place. You learned about significant figures or approximation. So significant figures and numbers after the point going in this side here. So give it to 1 decimal place. If it's an angle, take note. So in this case, the decimal place is basically the 6 here. So you see that the number next to this 6 this side is actually 5 and above. If it's 5 and above, we borrow a 1 from it and add it to a round off digit here. So 1 plus 6, that's a what? That's a 7. So therefore, we have got 33.7 degrees. So this angle theta is therefore approximately 33.7 degrees. So how did we get this one? We used one of the 3 trig ratios, and that is to say the tan, ratio there, the tangent sine. The tangent ratio there. So basically that's what you need to actually understand. You need to know these things for you to be able to actually understand all these things here. However, with special angles, there's no need of using the calculators. But of course, you should have such knowledge. What do you do there if you've got this and that? Okay, very, very important. Remember, we haven't yet started looking at special angles. I'm just giving you the prerequisites or the knowledge you ought to know. Okay, very, very important. Okay.